we were going to start inside today, and I had some slides and I had some prepared remarks, but it was such a nice day today, and I realized that it might be a lot nicer to start outside. So hopefully you guys can hear me okay. There's going to be a little bit of wind, but I just think it'll be a nice experience to do a demo outside, do some listening outside before we go inside, and everything sounds terrible, right? In terms of alignment, we all know it's a lot harder to do alignments inside than outside. So I thought, let's start with something a little bit more clear, and then we'll move inside in a little bit, take a little break and get reset up. So thank you guys for being here. As you can see, I'm sort of skipping all of the introductory things that I normally do, and we'll probably just go straight into listening to some stuff. So I have some speakers over there. Let's see, if I walk over here, will the camera follow me? So there's a subwoofer over here, and there's a main over here. And basically what I did was just put them as close together as possible so that we can I'm trying to remove any problems here. So I put the speakers right next to the wall so that I put the speakers as close together as I can to remove any distance offsets. And so when Fede comes back, I'm going to ask him what he would do in this situation. And then we're going to see if we can get these things maybe aligned by ear. And then we're going to look at how we might do this with SubAligner. So I guess I should ask you guys, since you're here already, what would you do in this situation? What is your sort of go-to method for doing an alignment by ear?
I mean, usually my approach for sub-time alignment, it comes down to the number of cabinets that I'm using and also the configuration. If I'm doing end fire or cardioid, that's going to factor, of course, with, in a corporate event, how much space capacity I have out there in the field on downstage edge, or if I can put it upstage behind drape. So, I mean, the simplest thing that I look at is delay timing, of course. That'd be the quickest way.
So I'm gonna interrupt you because specifically I want to know about this situation. So I just have one sub, one main on the ground, and I want to do it by ear. So how do I do
that? Couple different ways, but my approach would be one sub, one main on the ground, straight by ear. You could do a playback track of click timing, so do a single sine tone or a click tone, and calculate via timing on that with quarter notes, or you go by the old formula of delay time measurement.
Okay, I say I don't have any other tools, so if I do a sine wave, then what frequency should I do that sine wave at?
Something with modular tone, so maybe 85 hertz, maybe something centered 100 hertz.
And why do you say 85 or 100?
Well, the frequency response in that box, I'm not going to go anything two pitch and be a sine wave, not a square wave, because I feel for that's the type of tone that I can feel it. And I can hear it snap in time with the PA, because I feel like the crossover between the top cabinet and the bottom cabinet would probably register between those two. Whatever the top box is. I mean, if the crossover point's 67 hertz, and if you're able to snap them both around 90 hertz or 85 or 70, somewhere in that zone, I feel that would be the great approach, just so you can feel the timing on snap.
I'm going to give you a little bit more information. So I'm going to show you a plot of what they might look like together. Oh, obviously, this includes a preference with level offset, but if I zoom in here, now that you see this, now what frequency do you think I should choose?
It's looking like your node is 110, 115, no, like 109. That straight cross node at about, what is it, negative 12 dB?
You're looking at this line, or you're looking here?
I'm looking at the red line. Your cross node between red and blue.
Okay, so yeah, 107?
Yeah, about 107. Yep.
So is that the frequency you think I should use?
Yeah.
Okay. Okay, so I've got a sine tone. Now what do I do?
And is our tops and subs one on top of the other? I don't see your field setup. Can't really see it.
Maybe if I walk over here, you can see better. So they're right next to each other. So here's the subwoofer.
Okay.
I don't know, the camera might be too far away, but they're basically right next to each other.
Yeah, side by side, dead on. Well, so now the next step would be is push tone, and you have two separate sends going, I imagine, on both box and sub.
Okay.
So, and then do you have where's your delay configuration then at that point? So yeah, your output. So
yep, I got my outputs. Everything's at 0.
Mm-hmm. So match attenuation. So one's not pushing harder than the other.
Okay. Yep, everything's the same.
All right. And where's your delay timing? Oh, I see it right there, the bottom
Tiny,
right corner.
but it's down here.
Yeah. And then at that point, start adding in milliseconds and just listen to it by ear. And if you don't have any tools, you're going strictly by ear. You got to listen to it strictly by ear, and where you feel you're going to hear that hollow snap come together.
Okay, so I start adding delay, and I'm listening for. Tell me about the snap that you're talking about.
So it's like, ideally, like when I use Smart, I'm listening for the curvature of the crossover between my array and then the subs itself, and basically with the attack time in between the two. And follow and realm with ADSR, I'm listening for the overall snap when you basically have a lot of mud or too much bellow coming out because they're off timing. So the crossover point of the PA and the subs obviously aren't matching. So what I'm trying to do is I'm trying to factor with the delay timing to have these two meet as in time limit on dead unison and at that crossover point. So I'm listening for the suction kind of snap because you can hear it, and ideally you can feel it too.
This word is a little bit foreign to me, so let's talk about maybe summation. So it should get louder or quieter?
Should get louder.
Should be louder. Okay, let's do it. So should I add milliseconds of delay or 1/10 of a millisecond?
I start off with 0.03 of delay. That's where I start off with.
Should I do it to the main or the sub?
Sub.
0.3.
I mean, this is my approach, as I'm listening.
I know. I'm testing various approaches. So I don't hear anything yet, but I'm going slowly. It could be getting louder, but it's almost so slow that I'm having a hard time telling. Do you think it's getting louder? No, I can't hear it. It's hard to tell. Okay, I'm gonna start going faster. Oh, now it's getting quieter. Yep. Okay, it's getting a lot quieter. Quieter. Now it's getting louder. Okay, so this was the quietest.
So 8 milliseconds on your sub, 10 milliseconds. Yeah, that's pretty far too. Ideally, if your tops and your bottoms are dead on top of each other,
that's getting quiet again.
Yeah, that's gonna be.
Okay.
It's not gonna be
that. I think this is the loudest. Okay, so this is the loudest that I heard. 13 milliseconds of delay. So what I would love to get Fede to do is, since he's got his audio analyzer set up, now we'll actually measure it and see how close I got.
Okay.
So this may take a minute. Thank you everyone for your patience. Fede, is there anything I can get for you?
I'm just gonna bring the mic stand.
No, we can just put the mic on the ground. Plane.
Okay. I have one.
And I'll mute these outputs.
Do I use my laser, or do you want to use yours?
Oh, we don't need a laser yet. We'll just take an acoustic measurement.
Okay.
Wow, look at this. This is amazing.
Yeah. The windscreen.
Oh, and it's screws on there?
Yep.
Oh man, I lose mine all the time. This is brilliant. So this came with the mic, right?
Yep. That's part of the kit.
So over here is probably okay. Okay. And then here's the outputs.
You can move it if you need to.
Well, if I just get a little bit more slack on this cable.
It's kind of short though. There.
All right, so now you have output. And actually, will you also, well, let's get your audio analyzer running and then we'll start Zoom so everyone can see your screen.
Okay.
Everything's muted over here still.
Oh, okay.
Feel free to turn stuff on. Come out, mute it.
Yep.
Okay, here we go. There's the sub. There's the main. So I'll leave the sub off.
You want to do pink?
Yeah.
Noise or okay. Yeah, yeah. And the glaze noise instead. So. Cool. You want to pause that? No, I could download it. Yeah. If I can get into my.
So we'll get Zoom open real quick and then everyone can see your measurements.
I'm not getting Wi-Fi from here. Is your
muted? Yeah, let me mute it. And muted.
All right.
So I'll show you the network to connect to.
Oh, yes, it even show
Yeah,
up.
it's that one.
This one right here.
Yeah.
Hit. Good life, I think. Yeah. Cool. What? What is this?
Why did you unplug your interface? Did it have a problem?
No, I was about to go inside to pick up Wi-Fi, but
Oh,
so weird.
oh, here's your power.
I don't think it's because of that.
Oh, okay. Okay, so while Feta is finishing
Setting up.
getting Zoom set up so that you guys can actually see his screen, let's do another listening test because I can store these settings and come back to them later. So who has another method I could try? Feta, do you have a method that you use for doing alignments by ear?
No, honestly, no.
Okay.
I usually use a Smart or any analyzer.
All right. Well, we already had the suggestion of listening to a sine tone. So what is another method we could use? I think somebody mentioned, I don't know, what is another method that you guys have used in the field or tried or had some success or failure?
Yeah, you could use a sine wave and try to have the similar distance to both speakers and then try to maximize you could do the vice versa to have one speaker polarity changed and then get the maximum out of the interference.
Okay, so you're saying same test we just did, but this time with the polarity inversion and listen for cancellation instead of summation.
Yeah, that's another possibility, yeah.
Okay, let's try it. So we'll just remember here that our first option 1, 13 milliseconds. I'll reset this. And so you're saying polarity invert this and do the same test, but now listen for the cancel. Oh, I gotta take the playback channel back.
It's right here.
Okay. Is it muted? Yeah. Here. Okay. Play. Okay, this time listening for cancel. Okay, 3 was the lowest. Is that Michael? Yeah. We blocked the road. Okay, I think 3 is the quietest I can get it. So now that I found that, now what do I do?
I guess flip the polarity back as it was, right?
Flip the polarity, okay.
And you should hear the summation.
Did you get Zoom installed?
Not yet.
Not yet. Oh yeah, so now it's really loud. Okay, so now I have a second option. I have, oops, I gotta go back here. Option 1, option 2 is 3 milliseconds. So, is there anything interesting about these two numbers that you guys notice? 13 and 3 milliseconds. What's the difference between 13 and 3?
10.
10. What
Yeah.
is
Yes, 10.
what frequency does that tell us? What frequency has a period of 10 milliseconds?
That's a great question. I mean, the speed of sound travels at 343 meters per second. Does
anybody know what frequency has a cycle of 10 milliseconds? Does anybody know what frequency has a cycle of 1 millisecond? Maybe we can get there that way.
1K.
1 kilohertz.
Mm-hmm.
So 1 kilohertz is 1 millisecond. Then what frequency is 10 milliseconds?
Oh, 100.
100. Okay.
Yes.
So is it possible that both of these are correct, just one cycle off?
Yes.
Thing, right? So I got there, but one of them is a cycle off. But that's the deal with this method, right? Is it's hard to tell if you're one cycle off, half a cycle, 2 cycles. And this is what I've always struggled with, especially indoors, right? It's really hard to tell how many cycles you've gone around. But I want to see if we can still do a measurement. So what else do we need to do on your computer?
It's updating. Yes. Yeah.
Oh, it's updating. Oh, no.
So
Okay. Well, I can grab my audio interface and maybe just use your setup.
Yeah.
Okay. Okay, while we're getting this set up, are there any other listening tests that anybody wants us to try?
Yep, I do have one.
Oh, what's that?
Would you care to try the same thing, but then use some filtered noise? For example, use like 1 octave or 1/3 octave pink noise. Since we're trying to align like the whole crossover band,
Sure.
I guess it would be better to try and maximize the summation in the whole band instead of a single frequency. So I was wondering if we could get similar results. Of course, assuming that the subs and the main is somehow phase compatible in the region over there.
Yeah, band limit and pink noise. Let's try it. So I just plugged in my audio interface. Hopefully it's going to show up here. There it is. So the reason I put this speaker stand here is exactly because I was afraid someone was going to drive through.
Oh, I see.
Wow, that's a lot of trace captures.
Okay. So you were saying, let's try some band limit and pink noise. So pseudo random. So what range should I choose?
Since we know the crossover frequency, we could like center that and then try to do something like 1 octave or 1/3 octave or half an octave.
Okay. So if we are saying that there's a frequency right in the middle that is 107, so how do I find an octave or a half octave around that?
Since this is the central frequency, what we're talking about logarithmic spacing, then this should be the square root of the edges.
Okay.
That means that this frequency is the square root of lower times higher.
Square root of,
let's say
some
F1
frequency
lower.
times higher.
Yeah, should be something like that. And this should be some like, yeah, I guess that would be fine.
So I'm just guessing. There is a formula to find these numbers, but I don't know what that is. So 55 to 200 would be 2 octaves, but you were saying 1 octave. So
yeah, whatever. I mean, it could be like 1/3 octave, whatever feels easier to start with.
Okay. Okay, that's closer to an octave.
That's good enough, I guess. I mean, it doesn't really make such a huge difference, I guess.
Okay.
A couple of hertz lower or higher.
And how loud is this going to be? Let's see. Nice. Okay, so now I'm just saying,
What is it? I'm looking
for cancellation. I'm going to lost control. Let's see. Yes, I lost control. Oh, since it's not playing, it'll do it. There's, okay, there's again. 1, 2, 3, 4, 5, 6. I'm going to go changing. Any changing. It's not a little bit. I'm going to get quieter, louder. Maybe it's a little louder. Oh, that's okay. Okay, I wasn't able to hear any change there. Do you think maybe there was something I was doing wrong, or do you think there's something about this situation that makes that one not work as well?
Maybe, I mean, this should be phase compatible for this to work. I guess otherwise you just hear like some comp filtering and stuff like that, which, as you said, might be like the tonality change. So this may be like a completely invalid method if they're not phase compatible.
Yeah, I was wondering about that too. So Nathan, like in your experience, I mean, if you have like if you got an RCS speaker compared to 1100 Meyer sub, how much is an offset on that if they're dead on top of each other as a physical alignment compared to that for tonal alignment? Where's that coming to realm on the response? Even though they're physically dead on with the surrounds, but the response between the two and the crossover point between different cabinets, that's what I wonder between their phase compatibility.
You raise a really good question. So I didn't tell anyone what these speakers are, so now I'll tell you. So it is a DB Technologies Opera 15.
Okay. A
little point source speaker that you just put on a stand, and a little subwoofer from QSC, a KS112. So two different speakers, 2 different designs, 2 different brands, not even the same manufacturer. So yeah, we have some doubts. Should we even be able to hear summation between 2 different products like this? What do you guys think?
I mean, it all comes from the processing.
Well, I guess you can, because I guess you can have a submission, because they both position an output, and when there's an output, I guess you can have a submission of those 2 different boxes if possible. Once you have audio or the signal running through them, I guess it's possible.
But I mean, the question is though, are they nominal on output for the tone? So in timing, between the driver, the compression driver, the spider, and the cone, is each speaker pushing at the proper amount of time as the other one is doing it? That's my question on it too, because different speakers are going to have a different amount of output push than other ones. So some are going to be quick and responsive on the neodymium or compression driver rather than other ones. That's going to factor on with overall alignment too and response. I mean, if they're physically in linear mode on X and Y axes as best as possible, and everything from the back end push is coming nominal to it, but all the internals of the cabinet itself are different and responsive. That's the variable right there to account for. That's my question on it too. Like how to account for that, how to register that. Because I mean, with the tools and everything in mind, that's the question of the science right there, is how well you can divvy down to that, knowing exactly the response timing.
Let me interrupt you for a second here so we can move along. So I think you raised important questions. I don't know anything about the way these are designed, but I do present you with a further question, which is there are lots and lots of AV companies that have lots and lots of speakers like this, and they send them out together all the time from two different brands. So if it were impossible for these speakers to be phase aligned, it seems like that is something that they would know about. It seems like that would come up on sales calls. It seems like that AV companies wouldn't do that if it were impossible. So it's still possible that they're not phase aligned, but I'm placing that sort of idea in your head. Like if this were so hard, I think less companies would have two different brands. But let's find out. Let's actually take a measurement and get to the bottom of this.
Nathan, what's the password
for the
network?
The network, it's a good life, all lowercase. Okay, so I'm going to reset everything here, and then we'll mute these guys, and then we'll see if we can get a measurement going here. Okay, and I'll switch back to pink noise, but I'll turn off the pseudo random thing for a second. Hey, there's my name. And now let's do the sub and let's go through the different options that we had. So we had 13 milliseconds and then 3 milliseconds. So let's try 13 milliseconds first. Okay. So let's see what you guys think about this. So it looks like we are level matched. That's good. And it looks like we did get matched. We were shooting for 107 hertz, I think, right? So let's come back here.
Yeah.
107. And so where did we end up at 107? Let me hide this. Hide floating meeting controls. And so if I turn this off for a second, and we go to 107, wow, look, we got close. I mean, we got right on around 107, around 100, but not everywhere else, right? So this is the little problem we were talking about. When you just listen to a single point, you might get that single point correct, but then you might be a little bit off everywhere else. So let's call this 13 milliseconds. And now let's try our second solution, which is 3 milliseconds. And it looks exactly the same. Did I do something wrong here? 13. Oh, I'm on the wrong channel, sorry. Let's go back and do that again. 0, output 4. 13 milliseconds. There we go. Okay, so recapture. Okay, so, wow, 107, we're actually way off. But here it was correct. So maybe I was actually hearing this frequency. Anyway, that's 13 milliseconds. Now let's try 3.
Getting closer.
There's 3 milliseconds. So, oh, it's polarity inverted still. That's why. You guys, I'm making so many mistakes today. Recapture. Let's just double check. This one's at 22.7. This one's at 22.7. A lot of wraps there. There's 13. Okay, hopefully I did it right this time. There's 3. Okay, 3 milliseconds. So whatever happened with our hearing, we were hearing something, right? So maybe it was aligned here, and so we heard it get louder. Maybe it was aligned, where else? Yeah, it looks like that's it. So maybe we were hearing this, right? Because our ears are sensitive to higher frequencies.
Mm-hmm.
So that's where we heard it aligned. And then with this guy, we got to get rid of this. There we go. Maybe we heard it aligned here. And so I think I wanted to go through this to show sort of that I think this sort of simple, like single point listening test can be misleading.
Mm-hmm.
And we might hear this one tone and we might think that it's all good, but we didn't quite get there. So let's try SubAligner and see what SubAligner gives us. Okay, DB Technologies, Opera 15. That's the processing preset. I just sort of selected it at random. It was already on there. I have one of them. What's the distance? Do we have more? Do we have more people who use imperial units here today or more people who use metric units? Let's do a quick poll. So type into the chat, do you normally use meters or feet?
I use meters.
Okay, a lot of
Meters.
people saying metric.
I think your router is making my laptop crash. I don't know why.
Oh no, I'm sorry.
No, it's fine.
All right, well, don't worry about it. Okay, most people are saying metric, and let me answer Dwayne's question. How would you decide which elements to add the delay to, subs or mains? Well, so this is another problem I was trying to expose, is that I was putting you guys on the spot, and I was saying, okay, which one do I delay? Well, you have no idea, right? That should have been, the real answer should have been, I don't know. But what we do when we get into the field is we end up making a lot of assumptions, we end up making a lot of guesses, and we really don't know. So as you saw, as you'll see in a minute, we actually chose the wrong element to delay. We'll never get there by delaying the sub. Okay, metric. So we're going with metric. So let's see if I can remember how to change this. This guy to inches. No, meters. There we go. Okay. So I'm going to stand here where I've been listening, and I'm going to basically put this laser where my ear is. And, oh, it's turning itself off because it's running out of battery. Okay. And I'm going to attempt to shoot that speaker, even though It's tough out here in the daylight.
Okay, try this.
Are you going to put his? No, go ahead. That'd be great. Okay. Cool. So yeah, I got it. 6.896. Nope, turned itself off. Well, let me type this in before we lose that number. 6.896 meters. And now the sub. Oh man, do you have any AA batteries? I mean, AAA batteries? This thing is going off and on.
You're gonna use mine. It's already in meters.
Perfect. I just press the on button.
Yep. I think there is one that says measure me.
On. Oh, there we go. I'm actually going to measure to that wall, though. Yeah. So 7.057. 7.057. And this is the preset that I'm using with that sub. And so SubAligner recommends delaying the main by 11.33 milliseconds. So I don't know if this is going to be correct, right? Maybe this is the first time I've ever used SubAligner. I don't have any confidence in it yet. And that's totally valid, right? Always test but verify, that kind of, trust but verify, that kind of stuff. But if this is true, then yes, I chose the wrong element to delay and went way off in the wrong direction. So let's try this, fingers crossed. So 11.33 milliseconds and a polarity inversion in the main. Uh, 11.33 polarity inversion. Here we go again. By the way, don't be afraid. This little exclamation mark is there anytime you change the speed of sound. So I got here before you guys today. I have my little thermometer here, and I set my speed of sound so it's slightly different than normal right now. Okay. Sorry, that was loud. So this is main 11.33 milliseconds inverted. And our sub. Okay.
Oh, wow.
Looks pretty good, right?
It nailed it.
It nailed it. So I set you guys up, right? I knew this was all going to go wrong, and then it would work out with SubAligner. So let's listen to this now, because we got to listen to the other ones, and we didn't listen to this one. So let's listen to a sine wave like we were listening to before. Let's listen to band limited peak noise, and then let's listen to some other test signals that I would recommend instead of those. So, sine wave, we were listening to 107. And what my expectation is that it's going to be loud when I turn it on. It's going to disappear when I hit polarity inversion, right? As it should. And then that's what I'm expecting. Okay, let's turn this on. Oh, because we're not listening to both. There we go. Okay, it got a lot quieter, right? Comes back. Okay. And then we wanted to try band limited pink noise. Pseudo random. This is where we were before. Okay, let's go. Let's make it louder. Let's do this again. Okay, yeah. So now we could hear it get quieter. So all of these methods work if you're in the right area. If you have the right settings, they all work. But I think the reason that we didn't hear anything from the band limited pink noise before was because we were so far off. So whoever suggested that, I didn't catch your name, but he was right. I think we just heard comb filtering, right? We heard changes in tonality. Okay, so what do I recommend instead? Well, I recommend the thing that's built into SubAligner, which is that after you go to the results page, then you go to this page, and I usually like to start with either the red or black pulse. And I have to change the output. Let's try again. Let's see. Evo 8. Play. Nothing. Maybe I have to reload this page. I'm not sure. I don't know if you can change outputs in the middle of running something. Seems like I broke it. If it doesn't work, we can always play it from here, but I just thought it would be good to show it in the app. So normally the way I would do this, or the way you could do this, is I would normally run this on my phone and then just plug the output of my phone into the mix console or the mixing board or something. So I just wanted to check, like, what are our audio settings here, and then maybe they don't match to whatever the Mac is. Let's see. That looks okay. Okay. Well, let me just try closing Chrome and then reopening it.
So when we were doing the listening test, we chose 100 hertz as our frequency. Why 100 hertz and not 95 or 90? Is it because of that's the crossover point between the sub and the top?
Yeah, so I cheated a little bit because I opened this up in SubAligner and I looked at the plot, and there's a line here that shows you where the center of the crossover region is.
I see.
I just zoomed in here, and then someone else suggested, hey, you should choose this point right where these two match in level, which I thought made sense.
Right.
Okay, let's try this again. Okay, some little bug here in my computer. That's fine. We'll just do it in Smart. So I open a file. I have all this stuff on my computer as well. And then I've got all of the color pulses, which you can download from Merlin Van Veen's website. Okay, this is basically a proxy for a kick drum. And then I would do the same thing here. Is this the right setting? Yeah, I hear it get quieter. The tonality changes, sounds bad. Okay. And the other one that I like a lot is the red pulse. I like the slower one. So this one's louder. Same test here.
And where are you getting those files from?
If you just search for Merlin Van Veen color pulses, you can download them from his website.
Gotcha.
Yeah, I'm gonna type that into the chat. Merlin Van Veen color pulses. Yeah, so just to summarize a little bit and see if there's any questions and anybody wants us to do any more listening tests while we're out here. We tried listening to a sine wave. We tried listening to an inverted sine wave. We tried listening to band limited pink noise. And they all gave us various results that got us aligned at one point or another, but not through the entire crossover region. And we were able to verify that with our audio analyzer. And so that's actually my common method in the field, is I'll start with SubAligner, while we're in a hurry, everything's going fast, and then at least I have an alignment. And then later on, if and when I get my audio analyzer set up, I will then verify that it turned out correctly. And as we'll see when we go inside later, the worse the environment is and the more you need SubAligner, the harder it will be to verify. And when you're indoors in a small room, it's really hard to verify that it's working, mostly because we as humans cannot be everywhere at once. And so we can't decouple. Well, let me save that conversation for when we're inside. So any questions about this so far, or any other tests you guys want us to do?
I do have a question.
Yes.
So I'm still wondering what frequency do we need to choose to actually base our listening test to, or the measurement? Like, it has to be 100? Could it be like 95, 90, 105? Is that dependable on the crossover frequency too?
I think one of the things we just learned is that it's not a good idea to just choose one frequency.
Right.
You should have the whole area in there. And so I don't think you have to worry about it that much. As long as you have something that is just in the low end, black pulse, red pulse, these kind of color pulses, or even just, if you have a kick drum or something. But what you want to do is desensitize yourself, because if you put on music or even a kick drum that has, stuff up in the upper mid range, your ears will be drawn to that. And it's hard to listen to just the low end, even though in some ways we're more sensitive to level changes in the low end. But if we can hear stuff in the high end, anything with voice in it will always be attracted to that. So I would say, don't worry about the frequency. Just pick one of these pulses that has kind of an attack and that is also only in the low end.
Right. Okay.
Yeah. And I think I have put some of these on my YouTube channel. I'll look for them in a little bit, but I think I have a whole series of test stuff in there that I can share with you guys later. Cool. Now, there's one more test I thought about doing, but we don't have to do. I don't know how fun it would be. I thought it might be fun to put the subwoofer on its wheels and just sort of make it go farther away until it disappears.
Yeah, let's do it.
You want to do that?
Yeah.
Okay, so let's you be the listener.
Okay.
And we'll play the sine tone again, and then I'll push the sub away, and you tell me when you hear it get quieter.
Okay.
So let's see how loud this is. Okay, that's pretty loud. Okay, so we're in agreement that it's aligned now. It's probably as loud as it's going to be. And so if you come over here and stand in my position, and then you'll hit the G key to turn this off and on once I get this set up. Okay, hit the G key and set. Still pretty loud? About the same? Okay.
Yep.
So tell me when you hear it get quieter as I move away.
Oh, right there.
Oh, yeah?
Right there. Yep.
Back this way?
right there.
Wow, we didn't have to go very far.
No, yeah.
Oh, wow. It got really quiet. Okay, so how far? We only moved like a meter, right?
Uh-huh.
So a meter
It's
is,
a quarter of the wavelength. No.
well, let's find out. So 340, do you use 344 for the speed of sound or 45?
44.
44. Divided by 107, we're still thinking. So that's 3 meters.
That's a third.
So let's see
Ish.
how far this moved.
Oh, let me get the.
Oh, that's okay. I think I can just hit the wall.
Okay.
So yeah, 7 meters, and now it's at. Oh. And now it's at 7.8. So we moved 0.9 meters. Huh. It seems like maybe maybe we went almost half a cycle.
Mm-hmm.
So let's find out. Let's measure this now. So go back to pink noise. And let's mute the sub. Wrong one. Oh, because we're doing band limited pink noise. Okay, the sub. Yeah, there we go. So we're 180 degrees off, all through this region where we can really hear these guys really well together, right? So this is surprising for me because I thought we would have to get a little bit farther
away.
So I don't know if you guys can see this. The camera is a little bit too far. Maybe I'll carry the camera over there in a second, but we only moved the sub
a
meter and immediately lost all of our bass. So I don't know what your takeaway is from that, but for me, it seems like, you know, this stuff acoustics can be pretty specific depending on the wavelength, right? 107 is relatively high compared to maybe like 80 hertz. So 344 divided by 107. So 3.2 meters is the wavelength of 107 versus 80 is 4.3.
4.3.
You know, quite different. So another interesting thing though about SubAligner that I always thought would be interesting to test, I don't know if we can do it here, but our last measurement was 7.89. So is it this one? None of these have the correct distances. Let's see. That's okay. I'll just measure this again. So anyway, the sub is 7.89 meters. And I don't know. Seven 7.042. Hopefully that's correct. So yes, there's these delay values here, but if you open up limits, it also gives you distances at your at these temperatures, right? So we need to change one of the distances by 4.85 meters. So we either need to move the main farther 4.58 meters away or move the sub closer 4.5 meters. Unfortunately, I don't think that's going to work here because we need to keep the sub coupled with that wall. Otherwise, we'll hear a reflection from that wall. But I think that's another problem solving tool in the field. If you are just going to go directly into your main and your sub with a single line, and you don't have a delay, you could still physically change the positioning of your speakers a little bit and have the same result.
Right.
Okay. Well, unless there are any questions, I think we'll probably take this apart, move inside, and then do the second part of this inside. Let's see, there's one question. Is there something I need to do to hear the tone he's playing? I can hear his voice though. Yeah, you guys aren't going to hear the tone because we're just using a little speaker. We're using Zoom. It's filtering everything out. So sorry about that. You guys aren't going to really get the same benefits of the listening test, but you should do this at home yourself and sort of prove this to yourself. You never really believe this stuff until you try it, right?
I'm doing this once I get my Lions back from taxes with my 1100s. I look forward.
Wait, say that again. I didn't. So you have 1100s and Lions, and what about it?
Oh, I'm going to use SubAligner. Well, I mean, I carry Leopards, Lenas, 1100s. I have USW, CPQs, UPJs.
Okay.
Yeah, I've got a full. I mean, we run a full Meyer house, so I mean, I've got variations, everything in my shop to fly it up and test it. So, I'm going to get with my mentor come up this week, Nate, and I'll send you some findings that I have on it with SubAligner and what him and I talk about it on it too to try to help him out in the field too. But yeah, this is pretty cool.
Yeah, that'd be great. So I have two requests from you. Number one, I'm always trying to get more field tests. So if you ever have time, use SubAligner, but then also verify with your audio analyzer and then send me your results, especially if it's wrong. I always want to find out if something went wrong for some reason. And number two, if you have any custom presets that you use, because I have all of the default Meyer sound stuff, like the standard PC curves and some of the starting points. Right. But if you have some settings that you use, like I always use this low pass filter at this frequency, you can take a measurement of that and send it to me and I can add it to SubAligner.
You got it. Yeah, absolutely.
Cool. Okay, well, seems like now's a good time to take a break. So it'll probably take us about 15 minutes to move this stuff back inside. But I will leave the iPad on so you guys can still sort of see what we're doing. And everybody can take a break and we'll see you back in here in 15 minutes.